Today we are looking at this 1541. This was sent to me by Steve from the YouTube channel 8-Bit Retro Refix, and you may well have seen it on his channel quite recently. He looked at a series of 3 drives and he fault-finded 2 of them, and the third one he sent to me. If you want to see that video, then I'll put a link up in the top corner there and also in the description below. So let's take a look at it and see what we can see. Okay, so visually looking at the machine, we've got this disk label sticker on it which has got all sorts of writing on it. Kernel ROM's OK, 6522 plus. Well, I think that's probably nonsense. We've got a strange hole in the front. We've got a missing drive activity LED. And if we look on the back, we've got another strange hole in the back. And also, we've got an interesting rattle. So first thing that we're going to do is take it apart. We're not even going to try switching it on, powering it up or anything like that. Let's just look inside. We have a deficit of screws. There isn't just 2. For those of you wondering what was happening to my 64 bread bin, because I still have not provided the follow-up video to that, you will see on here these are the 2 CIAs out of it. So those of you that said, oh wait, the timers are not counting it. Ooh, that rattles. That doesn't sound too good, does it? Anyway, for those of you that said the timers are not counting up, so therefore the CIAs were bad, well, yes, you were right, but that wasn't the entire problem. That video is still to come. Now that's interesting. There is a very big burn mark on the inside. That corresponds to, I guess, this inductor here. And possibly, it looks like there should be a capacitor there, and that is missing. So I'm going to need to look at another short board. This is a 1541 short board. I noticed that one of the vias is missing, and I believe Steve took that out and used it on something else. That is interesting. That suggests something has gone very badly pop, and my immediate guess is going to be a tantalum capacitor that would have been in this position here, quite possibly. I may be wrong. I will have to double check against another short board to find out. So what I'm going to do is take this board off, because the elephant in the room is this. And this is a thing that goes sort of here and does something. But it goes where this thing is. There should be a spring clip holding the drive shaft up through there, through that hole, and through that hole, and holding that on. And it isn't. So this, I think, is going to be the first thing that we must look at. Whether you're repairing vintage computers or floppy drives, or you're designing your own circuitry, at some point you are going to want a PCB. And this is where our sponsor PCBWay comes in. Starting at just $5 for a board of this size, you can get your PCB designs built, you can get shared projects made, and then a week later you will get a nice box like this containing your PCBs. And they come in all sorts of colors: blue, green, red, black, white, yellow, purple. And they don't just do PCBs. They do 3D printing, they do sheet metal work, they do CNC machining, they do a whole lot of things. Check them out, www.pcbway.com. I'm going to mark the outside of these connectors so that when we plug it back in together, we know that we are going to plug it in the right way around. And I'm just going to write 1, 2, 3, 4, 5. So, assuming that they are in the correct way round to start with, we know what order they're in and the fact that the numbers are out, so we know that that's how they're going to go. That's the LED. These are all the drive electronics and the motors, and this is the head. Again, we have a deficit of screws. There is just one here and one here. Let's take this one out first. I think these should have serrated washers, but they don't, because they normally sort of grip. This one does. Right, so that board can go out of the way. That, I think, is the wire for the LED. So the LED has actually been cut off or broken off. That's interesting. And this, that shouldn't be rattling about like that. This is the thing that governs when a disc is pushed in. So I'm not quite sure how that goes. I think it goes like that. But that needs to be screwed down in any case. Yeah, that's just loose. That spring goes, I think, over there. I'm not quite sure. I'll have to look at another image. Okay, well, let's take this drive out and see what we've got. So I'm going to disconnect that. We'll put this board to one side. I think we want to try and get this drive mechanism fixed before we worry about the PCB. So again, this has got a deficit of screws. I don't know where this machine came from, but it does appear to have been rather hacked about. These are ordinary case screws, so we've got plenty of those lying around. I think the other screws are going to be sort of like M3. At least I'm guessing that they are going to be M3. So now we need to take the actual driver, and yet again there's a deficit of screws. Somebody who had this machine really wanted the screws from it. If we get this working, I think I might replace the power supply with a Meanwell, because I like doing that. And this filter needs to go because there is a mean old reefer in there, and that is going to let out the magic smoke if it hasn't already. Okay, we'll put that to one side. Well, the underneath seems to be okay. This is an Alps mechanism, by the way. I don't have another Alps mechanism. The other machines that I've got are all Neutronics. So yeah, that LED has just been cut off. Now I think these wires just go back to this connector. So I suspect it's these two here. So we're going to need to put a new LED on there. That is not particularly a problem. Aha, there we go. So this, need to lift that up. This goes in here. And what we need is a circlip to go on there. I've got a little pack of circlips that I got off Amazon. I don't know if any are going to be the right size, but we can have a try. So I'm going to guess at this one. Actually, that does look to be about right. So I think that's in. There we go. So there does look to be plenty of grease on the drive rail. And that, I think, is in the right position. But I'll just adjust that spring. I think the spring is supposed to get underneath. No. I may be wrong. Okay, I've looked at some pictures of this and I've got this wrong. So this is actually supposed to go the other way round. So we need to take this out. So this goes, in fact, like this. Oops. And then we need to get this bit out to there, like that. There we go. So that is supposed to move like that, according to whether the disc is in or not, and that is the spring that I believe pushes the disc out. So let's have a look at this. Right, we're going to need a longer wire because that is not going to reach where the LED goes. So let us replace it. I think rather than pulling that all the way out, we're going to just splice a new wire onto it, red and black, and just extend that so that we have got the appropriate LED. We need to make sure it comes up through there. So I'm going to prep some wires. Okay, so I've soldered a LED onto a bit of wire, and I've gone with red. And I've 3D printed a little housing for it because the LED won't actually fit in the hole. You see, it just goes straight through. So this is in brown because brown's the only colour I've got. I don't have any black at the moment. So that goes in there like that. goes in there like that, and hopefully this is going to... maybe not. Evidently the mounting is something that is slightly different. At least not one of those. But okay, for the time being we'll just have it hanging out. I will print something else at a later time. Now that feeds down through there. And let's get some cable ties. We'll have some nice yellow ones. So there we go. The LED sticks out a bit at the moment, but I'll try and do something about that at some point. Now that seems to rotate quite freely. The belt seems to have tension in it. I'm just looking at the drive electronics. That seems to be okay. I think this is for the motor. All seems to be fine. Let's put it back together. So that is ready for us to test. I am a little concerned about that missing capacitor, and I'm going to go and check that on the schematic. Just looking at the other beadies. They don't look burnt. That was where we had the burnout on the lid. Okay, yes, I've looked it up. That is 10 microfarads, 25 volts. And it is a tantalum capacitor, and that will explain the burny marks. So I'm going to have to order one of those. So we are pretty much done for the time being, but before we go, we need to fill that hole there. So I've got my stack of 6522s. What shall we have? Let's go for that one. I've got my strappy strap on. These are supposedly new old stock. I suspect they're probably rebadged Chinese imports, but it has been tested and it does supposedly work. So there we go. The reason I suspect it's possibly a fake is because this MOS logo is different to the normal MOS logo, and maybe it's genuine, I don't know, but maybe it came from a different factory. If you happen to know, then please tell me in the comments. Right, we'll come back when we've got a capacitor for that. And then I think we are going to give this a good old clean as well. One week later and some tantalum capacitors have arrived. So let's take the board apart again. So this is where the tantalum capacitor was, and it looks like it's been cut out. Possibly it's been unsoldered actually, because there's no pass through on that. So I think we just need to clean that hole out. Has that got it? Yep. Big ground planes on both sides for that. So we're going to clean this up. Stay. With some IPA, because this board really is filthy. Quote, Ripley in Aliens, oh look, there's a clean spot. So the standard thing is the long leg is positive, but let's just check this under the magnifier. 10 microfarads, 25 volts, and yes, the long leg is positive. Double check that. Positive is nearest the edge. Because if anything's guaranteed to go bang, it's going to be a tantalum. That's why they call them little yellow bangy things. Well, they don't, but... Okay, that's it. This board is filthy, but before we clean it, we're actually going to see if it will work. So, tantalum is in the right way around. Okay, so we will connect this up to a Commodore 64 and see if it goes. Actually, before we do that, let us plug it in and switch it on its own and see if it emits the blue smoke. My guess is if it does, it will come out of the back here, because this could have a reefer in it, in which case we'll need to replace the mains socket. So standard IEC plug off at the mains. So we're looking for these two lights here to see what they do. Hopefully they will come on and one will go off. Three, two, one. And the answer to that is no. But the drive is spinning. And I don't think the drive should be spinning, so we could have a problem with the 6502 or with either of these 6522s. Let's break out the scope and do a little bit of looking around. Okay, I've disconnected the drive for the time being so that that is not a factor and we don't get distracted by the spindle whirring. I've printed out, you can just see there, I've printed out the circuit diagrams so we can prod around quite happily. So if we look at the circuit diagram, this is our input circuit. It goes out to 12 volts and out to 5 volts. Let's just turn it on. It's on at the back, simply so I don't have to keep poking around there. And we'll just control it from the mains. So first thing that we're going to look at is the power supply voltages. Let's just pick a chip. The chassis should be grounded so we can go from there. That's the DC volts. So let's go for the 7414 in this corner. This should be 5 volts and we've got about 1.2. And on the 6522 it's pin 20. So on these it's down here. Square root of a nuts piddle. Nothing. So we've got no 5 volts. Well, that would explain why we're not getting any LEDs for sure. So let's have a look, see where the 12 volts comes in. Okay, 12 volts actually goes to this thing here that we replaced, which is L8 and C15. This is the stuff that disables 12 volts from the read-write heads during a power up and power down. So we should see 12 volts on one side of that inductor L8. And I'm not sure which side, so let's try this side. Nothing there. Let's try that side. 12 volts. So, yep, okay, we're getting 12 volts. Let's turn it off for a second and unplug this. This should tell us what is coming off the transformer. So turn it on again. Shove that in there. Shove that in there. 4.8 volts. Okay, so that sounds alright. And then shove that in there. And shove that in there. 9.5 volts. I think that's probably okay. So, something in the power supply is dead. There's not much point in looking at what's going on the CPU, because with that sort of voltage nothing's going to be going on, which pretty much explains it. So, one of the things I had in mind for this drive was to replace the entire power supply with a Meanwell. We could still do that and basically just take all that stuff off and put a Meanwell in its place. I've got a Meanwell handy. We can do that. Shall we do that? Let's do that. So we have got ourselves a Meanwell RD35A. This does 5 volts at 4 amps and 12 volts at 1 amp. Now, that's plenty for the 12 volts. This is a 5 amp regulator, but I'm reasonably confident that this is not going to take 5 amps. So I think 4 amps is going to be ample. We can take the top board off, and this basically has to go in there where this is sat. And I'm going to use this and plug this into here as before. So we will disconnect that end, take this out, take this out. The reason that I'm going to replace this is because there is a refit in there, and that is going to let out the magic smoke if it hasn't already. Unfortunately, I don't have any replacement versions of this that have the filter caps in, so it's going to be an ordinary one, but I don't think that matters particularly. And then on this board we are basically going to take all this stuff off. Use this connector to bring the power in, and we will route via wires on the underneath, probably the 5 volts and 12 volts from this, which comes completely regulated and switched and is the weight of a feather. Bring it straight into here, and that will then go straight to the voltage rails, which we will need to wire that up because those are not directly connected to the voltage rails. And then to mount this on here, I think we are going to need to 3D print some sort of bracket. But we'll take this off first and have a look, see what's underneath. This has just got two, I think, M3 screws underneath. But we can probably 3D print a plate that we can mount that on. Right, these mount, I think, from the underneath. We don't need that to be connected anymore. So I'm going to cut that off like that to minimize the amount of bare wires just in case. So that's the transformer, big heavy chunky thing. Right, so that's going to go in there, probably this way around, to allow that to come through to the top. So we need to make sure that there is clearance. Clarence. And the answer is there is plenty of clearance. There's about 5 millimeters. I don't know if you can see. But we don't want that to be any higher. So I think we might need or want to take these brackets out. They are secured in by 2 big screws. But bear in mind that this is a lot lighter and it doesn't generate anything like the amount of heat. Okay, so that can go in there like that. Now we want a bracket that goes on the bottom there. Is really no higher than that. And we'll screw probably there. Something like that. You can have it over to that side or have it in the middle. I don't think it really matters. And then underneath we're going to have plenty of space for the bracket to go there. Right. I will go away and 3D print something that will work as a bracket. And at the same time I will see if I've got a nut for this, because that will actually work to hold the bracket on. Right, so I'm going to put that aside while we're doing that, and let us go and have a look at this in the meantime. So this is the circuit diagram, right, this part here. So we've got bridge rectifiers C1, C4, C16, C17. So this is C16, this is C17, so that's these two. So let's take those off and clean the board up. So now let's start to take the rest of this stuff off. Basically everything that is not There we go. Now we just need to clean the board up and put some wires on. Okay, I'll clean this up and come back. Right, so that's done. I got the glue off. It's just bendy rubbery stuff. Just peeled off quite easily. So we need to check which are the two outputs from here. And VR1 is 12 volts. VR2 is 5 volts. So this is the 5 volt one. And that is the line that goes to all the chips. So that is the output. I'm going to mark on here plus 5 volts. And similarly, this is 12 volts output. So this one is plus 5. This one is plus 12. And then we're just going to connect that to that, and that to that. And these middle two are going to be our ground. So what we're going to do is wire these middle two to ground. That's going to go to 12 volts there. That's going to go to 5 volts there. And that is going to be our connection. I've got some wires. So these are going to be color coded. Black is ground. Red is going to be 5 volts and yellow is going to be 12 volts. 12 volts goes to 12 volts, 5 volts goes to 5 volts. Yep. And these go to ground. Yep. So that's this board done, and we'll just finish it off with a bit of Captain tape. There we go. So now we just need to build the base. What would be nice is if I actually remember to turn the microphone on this time. So we have got the chassis and the meanwhile, and over here the PCB. Now I've drilled out the socket, so there's still a bit of rivet in there, but yeah, you didn't need to see that. With my drilling skills, or lack thereof, so I'm going to hope to keep this on here and just unsolder it. if this will gradually thaw out the solder. There we go. You may be able to reuse that. Probably won't be able to reuse this. In any case, we don't want to use black. We're going to use good European colours. None of this monochrome black and white nonsense, because I never know what it means. There we go. And that should just come out. There we are. 250 volts, 3 amps, 50-60 hertz. And you can see there's 2 reefers in there. So we're going to replace that with just a ordinary socket. I'm just going to give that a little bit of a wipe. Get some of the cobwebs away. So just to remind ourselves, that is live, that is neutral, and that is earth. So what we're going to do is we're going to take the live wire from here to the main switch, then it goes to the fuse, and from the fuse it's going to go to the mean well. A couple of M3 screws. Changed my mind. I'm going to take this off because I don't like the fact that it's not got any kind of heat shrinking on it. I'm going to take this off as well because that's going to be too short. Okay, there we go. Look at that, lovely. Now let's see if we have got the right size when it comes to our bracket. This is the 3D printed bracket that I've made, so the mean well should screw onto that, and then that should screw onto that, and hopefully that will still be clear. So, yeah. Screwer of screws. Right. So you've probably seen the floor. But fortunately, what we need to do is take this off, put this onto here first. We are making this up as we go along, you can tell. Right, so this goes like this. It could go like this, but that will put it a little bit further forwards. So I prefer to have it because that is not quite in the center. So that puts it out there, which is more over the ventilation. That was my intent. Now these are designed to captivize these screws. Rather like that. Isn't that a good idea? So we are reutilizing the original bolts, and I overthought that a little bit, so this is actually, this could come down by probably a couple of millimeters if I decide to reprint it, which I might, but I'll do that off camera. These are M5 nuts that I've got from the wonderful place of Amazon. But this is kind of a proof of concept, and as such I think that works rather nicely. The only issue is going to be when we have got that in, is this now going to be too high? And the answer is no. Good. But there will be even more clearance if I reprint that slightly smaller. So it took about 2 hours to print that. And I think that's done rather nicely. So we just need to fit these wires in. So now we want these off the original transformer. Now we've got it marked on the board, so we know that it goes on there like that. This one is +5. These two are going to be common. So that's our common, and this is going to be our 12 volts. Right, there we go. And we'll put a couple of cable ties on there. So there we go. So that will go on there like that. Comes out, goes on there like that. And just to see the fit. Okay, can you see down there? Hopefully you can see fresh air out the back. Which is a good sign. So clean this up. I shall heat shrink those heat shrinks, and then we can test the power supply. So heat gun on the lowest setting, which is about 100 degrees. Moderate fan. And there we go. So here's the moment of truth. It's plugged in, mains is switched off, this is switched off. Let's turn this to volts. We are not connected to anything. let us see what we have. Right, I'm going to switch it on there first and then switch it on here. Green light has come on, that's a good sign. So on the primary, 5.08, and on number 2, 11.66. So that works. Let us now attach the board. So how are we going to know if it is working? We will plug in the LED. Segment 1 goes to segment 1. And we will also see if the drive LED works. Right. So mains is off, mains is off. Plug this in. Moment of truth. Green light has come on. Oops. That is a good sign. Drive LED is not going to come on because of course it's not connected. Right, we're looking for the drive LED and the power LED. Right, and of course the motor spinning. Came on, went out. Drive span, stop spanning. That is awesome. So that has done everything that it should do. Now we need to try it with a computer. Here we are, we've got a Commodore 64C set up and the 1541, and they are connected together in the usual manner. Right, that is on, powered, green light is on, red light is off. It flashes again when we switch the C64 on. Now I've got a disc here, it is an official 1541 test demo diskette. Branded and everything. We're going to stick it in the drive. Just test our eject mechanism. Yep, that works. So the eject is definitely fixed. That doesn't do anything when you put the disc in. I sort of expected it would. Okay. Make a note of that. Right, so do they talk to each other? No. The connection is good, at least as far as a reset is concerned, going through there. Let's stick a probe on the signals. Well, let's feel the chips. So, starting with a 6502. That's kind of warm. This is the 6526 that we put in. That is cool. This is the original 6526. That's kind of warm. About the same as the CPU. That's cool. That's cool. That's quite warm. Definitely warmer than those. It's not baking hot. That's mildly warm, not very warm. Cool. Cool. Those are all pretty cool. So that's warm verging on hot. That's warm verging on hot. That's pretty cool. That's warm verging on hot. So let's see if we've got any signals. We need to have a ground position because this is not a good ground. So I'm going to stick a wire into this ground plane, and then we will scope it. Ah, now that's interesting. I've just noticed the drive light is now flashing away 20 to the dozen. Let's take that out. It's still flashing away. Power cycle it. Yeah, something's going on there. Let's hook up this test point and then we can just probe some chips and see what's going on. Okay, I've tacked the ground wire onto this ground here, which we're going to use for the scope probe. The drive is off at the moment. I have adjusted the position so you can see it in the overhead camera. So the 64 is switched on. There's no disk in the drive. I've got my schematic here. There we go. We're just going to look at some signals, general signals, I think, to start with. So the red light is currently off. So let's look at pin 3, which is 511. So that is our clock. It's 5 volts. Pin 2 is ready. That's high. Pin 4 is IRQ. That's doing stuff. .40 is reset. 39 looks like a clock. 38. 37. That's our 50 in 1 megahertz. It's 500 nanoseconds per division, so 2 divisions is 1 microsecond. That's our read-write. Now we're looking at the data bus. That's D0, D1, D2, D3, D4, D5, D6, D7. Now we're looking at the address bus. Well, I would say the CPU is going, and I would say from the fact that we've got stuff going on that probably the ROM is okay. At least that ROM. Yeah, this I think is the GCR decoding ROM, and this is going to be the static RAM. So I think this is the CIA that controls the serial bus, and this, I think, I might be wrong, is the CIA that controls the drive. Oh, this light is blinking now. When I said CIA, I meant VIA. These are 6522s, not 6526s. So actually, no, I'm wrong. UC2 is the one that controls the drive, and UC3 is the one that controls that. So this is the cold one, which is controlling that. So maybe this is dead. Let's have a look. That's this one here. So I'm going to set up a command on the C64. Just the regular load $8. And we need to look at data in, which is PB0, which is pin 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not sure that that's right. $11 is doing nothing. 12 is high. 12 should be clock in. 13. Just look on the serial port itself. I don't know which pins are which on here, so I'm just going to proc. That is okay. I would kind of guess that that is wrong. So that's roughly 1 megahertz going on there. I don't think that's right. Let's turn this off. And let's take this out and just see if we see the same thing with that not in there. Because this is the chip that we changed, and it has the slightly unusual MOS markings, which might just mean it's a fake, and it could be anything. It says it's an R6522K on the bottom, which would be a Rockwell part, but it says MOS on the top, so I think that's a fake. But it may still work, or it may not. Right, so with that missing, let's power it up. Now the red light is blinking again. And that is doing nothing. Okay. Now that's interesting. The drive LED is blinking. That is normally a power on error code, and the motor is now spinning. See if it does it again. No, this time it's gone back to flickering. But that could be a problem with the 6502. It does seem like maybe this is dead. Let's try a different 6522 in there. These were all tested in my VEC20 at one point. That has got the conventional MOS logo. It's also got bent pins, so we'll need to straighten those out. Power up as normal. The flickering light has come back on, but we won't worry about that for the moment. Let's just look at this pin. It's got something on it, but it's not the 1 megahertz that we saw before. Okay, that's talking, and that's now generated a blinky error. So I think we can conclude that this VIA correction that I put in there is in fact a non-working VIA. They were not cheap. So let's try again, stick the disc in. This is where I could use a +4 with its disk commands, or a 128. But we've got the 64 at the moment. So I'm going to write a program to read the channel, error channel. Okay, so here's the program. Let's see what it tells us, if it tells us anything. Drive not ready. That's kind of not reading the disk. Huge apologies. The SIM card was full up on my top-down camera and I didn't notice. So at the moment I've got the 1541 diagnostic cartridge in the 64. The 1541 is switched on. It's currently not flashing the red light. I've swapped out the replacement VIA that I'd put in here, and currently they're actually swapped over. But now they are both warm. In fact, all the chips are warm and roughly the same temperature. So that's okay. I'm happy that the original replacement that I put in there was possibly a fake and didn't actually work. So one thing that I've done quickly off camera, I've traced through what I think is the signal for this LED, and it comes from this VIA UC2, which is this one here. You can't quite see because it goes off the page, but there we go. So this one here, UC2, has a signal ACT, which I think means activity. Comes off PB3, and it's one of the two that don't go through this gate array, and that goes to 7406, this guy, pin 13, and comes out of pin 12, so that is an inverter through this 150 ohm resistor, which is this guy here, and onto pin 9. So I've monitored that, and it's not doing anything at the moment, unfortunately. When it's flickering, there is a sort of bunch of milliseconds pulse going through there. It goes through there, comes out there, and that's what flashes the light. So it's actually, it appears to be coming from this CIA, and it appears to be a spurious signal, but I've swapped these two CIAs over and it still happens. So I'm wondering whether this 7406 is iffy. The problem I've had with the diagnostic test is that when I try and do anything, it just hangs. So it's not proved to be very useful at the moment. And the serial bus also goes through this 7406, and possibly I'm going to have to look to see what happens with this 7474, sorry, 14. But I'm wondering if that is possibly faulty, in which case we can replace that. I have got some spares. This is also an inverter. This is a Schmidt inverter. I've got some spares of that as well. That's another 7406, which again could be faulty. So yeah, this 7406 is all the motor and sync and stuff stepping drivers. That does seem to work, but I think I'm going to swap out these 7406s and see if that helps. There we go, it's flashing away there. So now we can have a look at the scope. So you see, that's what's happening. It's sending these pulses through, and of course that inverts it, and that is coming out of here, or at least it appears to be coming out of here. I suppose possibly the ROM is faulty. We could try another ROM. That's a non-stock ROM. Could, you know, could put JiffyDOS in there or something. If I do something on here, say, right, so the disk is in the drive. If I just say, let's try and read the directory, so D, and it just hangs. So that could be the 7406. I swapped out the 7406s and the 74LS14. I didn't film it because we've seen many desoldering montages, and this video is long enough as it is. But then I tested them in the Mini Pro. The 7406s, these two, were fine, but the 7414 had one dead gate. And if we have a look at the circuit diagram, okay, the 7414 is used in the reset circuit coming from the serial port. So it's the one there. So you can see it's going into the reset, and it also goes through there as well. So it's also involved in the data outline. So one of those gates, 1, 2, 3, 4 gates, was not working. So fresh one of those. I've put fresh ones of these in anyway. I've still got the originals. They've had their feet clipped, which seem to be quite common for Commodore. So let's put this back together and see if it goes now. Okay, here we go. The 64 is switched on. That's a good start. The drive light is not flickering, which always helps. So let's stick our test demo disk in and see if we can bring up a directory of it. Oh, yes. Let's do that again. Okay, now let's take this disk. This is just a gash disk, and see if we can do a performance test with it. That might take a while. That doesn't actually appear to be moving the head in towards the middle, so maybe it's having problems formatting this. It could simply be a bad disk. No movement of the head. Okay, I'm going to call that. It doesn't seem to be getting anywhere. No, it's not reading that disk. Let's just try another disk. There may be nothing on it. It is write enabled. At least you may not be able to see it from that angle, but it is moving the head in and out. I don't know if there's anything on this disk or not. It's just a gash disk. So let's just... Well, that's a shame. That didn't fix the problem. It could be the ROM. We'll just read the test demo disk again. Device not... I didn't turn it on. And that's basically when it's warmed up, so it could still be something that is failing temperature wise. Now, in case it's the ROM, I did burn a JiffyDOS ROM. Focus, yay. So we can try that. Let's turn this off, turn that off. Right, so the red light is out, but that may be simply a temperature thing. We don't know. We shall see if it comes back. Right. Directory on this. Yep, no trouble at all. Directory on this disk. Yes, okay, so that is readable. Now, if you recognize the files on that, don't worry, we will be formatting it. That's it. So, what have we achieved? We have fixed the clamp mechanism. We've put a new clip on the spindle. We've fixed the drive eject mechanism. We've replaced the drive LED. We still need to do something about that wobbling. We've replaced the power supply with a Meanwell, cleaned off the board, and I've 3D printed a shorter bracket which I can fit later on. Off it goes, knock knock knock. So I just reduced the height of that. That will give it some more clearance in there. That is fine. I replaced these 3 chips. One of them was actually faulty. 2 of them were okay, but I've replaced them anyway. And I fitted a JiffyDOS ROM, which it turns out that the original ROM was possibly faulty, and that seems to have been causing the problem with the flashing lights. So that's it, working drive. I hope you have enjoyed the video. If you've got this far, thank you so much for watching. Please check out my Patreon if you're inclined to support the channel in that way. The support that you give as a patron is greatly appreciated, and it does help fund doing repairs like this, buying components. That is another thing that we did. We replaced this tantalum capacitor, which was not only missing but had caused a big burn in the top lid. We have not at this time cleaned the case, but oh, and I found new screws to put in all the screw holes, so I can clean the case. There are some holes in the front and the back. Maybe I could put in a switch so that you could switch it out the JiffyDOS ROM. I don't know why you would want to switch out the JiffyDOS ROM, but we could also put in a switch that goes between drive 8 and drive 9. That's a possibility since the hole is already in the case. Yeah, so that's it done. Thank you for watching. My patrons are scrolling up the screen. Please mash the like button and subscribe if you haven't already, because subscriptions means better chance on the algorithm and more people seeing the videos. And let's face it, I would still make these videos if nobody watched them, but if somebody watches it, that's even better. So yeah, I'm waffling now, so I will see you next time. See ya, bye.